And here we go. Welcome to this special DXers meeting today. I am Daniele Vistalli, and here with me is Robert. We will host this for everybody, talking about running HCL DX on Kubernetes and attempting a live end-to-end sort of deployment to a Kubernetes cluster. I want to keep a very open discussion with everybody. So if you have questions, if I'm saying things that are wrong, don't be worried about correcting me. The plan is to learn and to share. So no problem at all. I would start with a poll about your experience with the containers and Kubernetes today. So I'd like everybody to answer. And please be, it's an anonymous poll, so I really would like to have real answers. Don't be a guru on everything. Because based on that, I will try to adapt the content and to challenge you, the audience, with questions so we can get out of these with some experience. Okay, and I can see interesting answers so far, but I want, as we have a good number of attendees, I want to see the full everybody to answering, and then I will share with you the outcome. I'm checking if everybody is allowed to talk, and Robert, please assist me with letting people allow everybody to be asking questions. Okay, so we have 17 out of 26 answering. So I want you all to complete the poll. The more data we have, the best we get.
So it's interesting. 80% of everyone here that has answered it is still learning. So you're gonna be the teacher today, Daniel.
Oh well, I'm still learning. I am also answering. I'm still learning because, and I like the attitude.
Well, and the good thing there is that there's some people out there. There's some people out there that will be helping you staying on the straight line. Please, the masters in our room that are doing this stuff already, help Daniel. Ask him questions, how he did it and why he's doing stuff, or what you found. So the second question that came up was, how much experience do you have? Well, 60% is still learning. So again, you're going to show us around on what your experience with Kubernetes is, but don't assume we know what you're talking about. So for some of us, it's still black magic. So Wizard of Oz, how does DX go on that cube then? Please share. Oh, by the way, more than 40 or nearly 40% have tried to get it running. That's pretty good.
Yeah.
I got it running on Docker myself on my laptop once.
Mm-hmm. No, in Kubernetes.
I didn't say Kubernetes, I said Docker.
Yeah, absolutely.
I assume that Sophie doesn't count.
No, Sophie doesn't count. OpenShift on your laptop or Kubernetes playing.
Sophie's got a count. Sophie's wonderful. This is Bill Swatley.
Yeah, Sophie, it's so easy. It doesn't count. It's like your oven. You connect the power and it works. Sophie just works.
That's a good thing about Sophie. But in most enterprise, in our environment, there's some guys from my office here today, and they have a challenge to setting it up. So I think it's interesting to see what challenges people will run into today.
Yeah, and maybe something to mention about Sophie is that HCL people actually have full access to that environment. So we can download the HCL distribution solution and use that download to deploy in minutes. This is not yet available for partners and customers. So it will change once we have a version that actually can be downloaded for you as well.
Oh, I love having a difficult life, so I always start from scratch. Anyway, I think we got well, 85 people participated in the poll so far.
85%, yeah.
And I think we wait for another minute and then we close the poll and share the numbers.
Close it.
I think I see that everybody is on the learning, on the learning side of things. And the most interesting thing is that I'm managing production workloads only at one positive answer. So this big word, which is Kubernetes, is discussed everywhere, but adoption is still something that's happening. So, and I'm not surprised about that. I'm not surprised at all. So it was good to understand where we are and to use that as the starting point for the discussion. I'm ending the poll now, and let's see. Oh, I can share results, so everybody can see the results we got so far. And this is interesting from my point of view. And people attend. Oh, I should have added another question. Have you successfully deployed DX on Kubernetes? But that's another story. And then there are many more degrees of achievement. Anyway, today is...
Would that be a 39%?
Yeah, 39%, but I mean, oh, no. What do you mean, Herbert? Sorry, I didn't get the point. Herbert?
Well, we saw that 39% actually tried to deploy DX with on Kubernetes. So I guess all of them managed to do that. So that's why I say it's 39% then.
I don't know. We will discuss that. Anyway, I'm now going to start my short presentation, and I will go through a bit of the basic things. So let's see, and you can see my presentation here. And this is the agenda. And the point number one is understand or fail. Kubernetes is complex. It's not more complex than doing things manually or the classic way. But as you are collapsing many roles on a single kind of management system, you need to have a better understanding of what's going on. And as a developer, you need to understand administration concepts. As an administrator, you need to understand development concepts. So this is important to understand. Otherwise, failure is around the corner. The second thing is about laziness and creating your tooling. And I will cover this, why I mean laziness, and you will see over the demo that you use a lot your fingers. So if you want to save time and to be able to do things, you have to be with a laziness, with a productive laziness in your head as a way of life. Then preparation is a must. I will cover a few things that you should never think that are not relevant. And then we get to doing the deployment of an HELM-based deployment of the DX environment. I have those optionals we will see based on the time we have, but you never know, maybe we can have deep dives about specific items in the future, because I want today to be as useful for understanding. You won't be leaving the meeting ready to, with a 100% success ratio when you go doing at your place, but you will possibly have more ideas about troubleshooting or what's going on when deploying on Kubernetes. And for sure, we will have we'll be answering questions, and when I say we, is everybody is welcome to answer questions. And of course, this is a live demo, so anything could happen. I hope we will be creating our own troubles for the objective of troubleshooting, and we will not have to spend too much time troubleshooting things. Okay, so this is a 2-hour session, and I hope this doesn't end up like this. So I hope to be engaging at some point, and if you think I'm going the wrong direction, please stop me and ask questions. So I hope it will be fun for everybody. It's Friday after all. One thing, because everybody's learning, I learned Kubernetes actually from the last line, paying the Linux Academy service. Maybe you have other sources. Cube Academy is a the second one is a VMware initiative, free for everybody, where they are providing information. Kubernetes IO and Kubernetes IO training are the official platform pages, and Kubernetes IO is the official documentation, which is a bit more formal, but is not the best way to learn. I had a very good experience with the Cloud Guru or Linux Academy because it's built as a training set of modules. So what I know, I learned there. And with a couple of years now of doing Kubernetes every day and over various kind of deployments, and actually running products in systems in production with Kubernetes. So I will be sharing a bit of what I learned. One thing you need to keep in mind when I say Kubernetes is managing your full infrastructure, and Kubernetes actually comes from the idea that we need to manage complexity by abstracting away concepts and orchestrating those concepts in a manageable way. So what I'm showing now is a short list of concepts that are also Kubernetes keywords, and I'm trying to match those to concepts you have in your mind, because there is actually nothing really new in Kubernetes. It's just more formalized architectural concepts put into what Kubernetes calls resources, which is abstraction for what you have. So we start from the ingress, which is an object. An object in a resource in Kubernetes is just a description of something that has to behave in a specific way. So when I create an ingress resource, I'm telling Kubernetes, please provide me a reverse proxy component that connects people to my HTTP or HTTPS application. Kubernetes has this as a key concept, and this in DX is covered in a specific way that I want to discuss later, because ingress is part of your infrastructure, and the DX team has taken a decision to use Ambassador to manage internal communication, which in the end I think will be a very smart move because abstracts things even more from your external infrastructure. Persistent volumes is like a disk, is a file system, is an object in your cluster that can be used by applications to store data. And PVC is a persistent volume claim. It's another resource that declares that you want to use, or that you request the infrastructure to provide you a piece of storage system for use by your application. So we will see the PV and PVC that HCL DX requires, and the reason that those are required, and the reason that we have those around. And we will learn that it's not different at all from what we have today in a classic deployment. It's just an abstraction of what we have today. A storage class is another component of Kubernetes, and is a sort of a label, a name for a kind of storage. So you can have a storage class which is very performant storage for my transactional database, and that will have specific characteristics. And then you can have another storage class, which is this volume needs to be accessed by multiple processes over multiple machines. And if you go away from the abstraction, this sounds like an NFS export. So once again, it's about abstraction. It's about defining things that can be mapped to real infrastructure. Moving on, a pod is a set of containers, and you know that containers are abstractions of a Linux process, and Kubernetes also exists on Windows, but I won't cover that. So a pod is a set of containers that have specific characteristics, and so ingress, persistent volume claims, storage classes, and pod are resources you declare and abstract things you have. There is another set or class or type of resources in Kubernetes, which is on the orchestration side of things. So a deployment, a stateful set, a daemon set are abstractions of a way to manage pods. So a deployment means that you are asking the system to run a number of pods in the same way multiple times. Those things are called replicas. So you can have a deployment of 5 Nginx HTTP server in a deployment, and that will work. A stateful set is similar to a deployment, and it's used in DX, and we will see how, but mandates the control of the pods in a way that's ordered. So you will have pod number 1, number 2, number 3, number 4, and so on up to the replicas you set, because this has implication on the storage that you connect to those pods. Daemon set is a specific kind of orchestration piece for pods that ensures that the pod is running on all or a subset of the nodes of your cluster, and is mostly used for management roles. Maybe you all knew about this, but this is a sort of the box of Lego bricks that we will use in building our infrastructure. Okay, and I've covered just a few, but Kubernetes has a large number of resources that go up to auto-scaling technologies for dynamically extending deployments and so on. I just wanted to give you the basic ones. And Kubernetes is also about extensibility. So when you need to handle a resource that's not part of Kubernetes itself, you can extend it with custom resources, or CRDs, custom resources definition, is a way to formalize an extension and to describe your resource into the Kubernetes infrastructure so that the automation can take advantage of that. And we will also see this because Ambassador, which is the HTTP aggregation solution that HCL decided to connect all the pieces, is using customer resources to define the way we reach to the various components. Okay, now moving on a bit, there is the other thing that you need to know and to have extremely clear in your mind, which is about persistent volumes and the storage story. When you install DX on a machine, or when you install any software on a machine, you are writing to your local file system, and in general, you are writing once. Only one process, only one system is using that storage. Kubernetes is per se distributed, so you have new challenges, and you want your processes to be able to move from node to the other and to continue operation. In that case, you need to have, and at times when you scale up, scaling is the process of increasing the number of replicas in a deployment or a stateful set. So when you scale up the capacity of your system, your deployment, you may need to access shared storage. And in that case, you need a read, write, many kind of volume. This is the case for DX because the WP profile, the profile for your portal, for your DX environment, is written in a shared file system, so that when you scale up your core WebSphere based DX environment, the profile is shared by all the pods in the deployment, and this ensures that all the pods are running the same application and the same artifacts deployed there. In general, the easiest way to have an RWX, a read-write many volume, is to mount. Oh, I'm getting there, Herman. RWX is mostly achieved mounting NFX exports, because that's the easiest and ubiquitous solution that you have around. So it can be mounted by many workers, by many machines. It can be accessed concurrently by many processes. So in general, when you use this kind of solution that's file-based, multiple access file system, you end up having something like NFS or very similar to that. So this is the case for the average deployment, and works quite well as long as your locking needs are not too complex and your random access is not too complex. There are, Herman has asked, what about storage provider like Ceph? Oh, well, Ceph is one of the enterprise storage provider systems that are out there. It's part of OpenShift storage manager solution, as far as I know, but you can also deploy that for yourself. Ceph is like a next generation storage area network, which allows you to have multi-node replicated storage that's exposed as block device or file system. We tried deploying that, but we failed because to have a performant Ceph environment, it needs to be very large scale, well above tens of terabytes. I mean, Ceph, in my experience, but I'd like to have others' experience too, makes sense when you have petabytes of data, because the way it load balances data over multiple disks makes sense when you have very large environment. Ceph allows you to grow almost unlimited, but also requires you to have 10 gigabits network interconnections only for the storage if you want performance. So it's an option, but for my experience, for the kind of scale we could have for serving DX is absolutely overkill. That's my experience so far. Today, I will be using an open source storage provider that's called OpenEBS, which is not performant the way I like, but I wanted to test it out, and provides me with read-write once storage that's replicated across the cluster, and also read-write many storage, which is actually a read-write once environment exposed through NFS. There are other things around, one is from Rancher. I don't remember the name. Andres, you remember the name of the storage?
Yeah, Longboard.
Say it. What's the name?
Longboard.
Okay, Longboard, yes. Also, Longboard is an interesting technology that Rancher brought forward. Actually, Longboard builds local volumes on your nodes and mounts those internally as iSCSI device that are synchronized across your host and then re-exposed as NFS or volume. So in the end, whatever the technology you use, you end up having a backing iSCSI or NFS volume. The one I never tried is an enterprise, very high quality product. I don't remember the name, but I will find that later. That is said to outperform bare metal storage because it can provide everything you need in a Kubernetes cluster. But as I say, the kind of access pattern we have for the DX environment doesn't require that kind of IOPS. A different thing would be if you run the database in Kubernetes. We had a discussion, I'm not entering this today, but for running DX, even with logs, even with transaction logs, we don't need that kind of high performance solution from my point of view. I'm ready to be proven wrong anytime. So it's important to have in mind those two, because for the media library component and for the core, you will need, and you will not be able to run on Kubernetes without this kind of file system. So now we get to the laziness part. Kubernetes admin is not and should not be, from my point of view, a point-and-click experience. It's all about command line and automation. And you, at some point, will be using your fingers a lot. So we need a way to save your fingers. In my desktop, and you will see that live later, the tools I use mostly to help saving my fingers is Visual Studio Code, because I think Microsoft in this case did a wonderful job, and the remote extension, so I can get into my remote machines from the editor, so I can edit files with my local editor and run commands remotely, and I will be doing that a lot today. Another thing that I love and I replace Bash with is Z Shell and its extension, Oh My Z Shell. I will show later what it does for me. And a few kubectl plugins. kubectl is the command tool for Kubernetes. It's actually a Kubernetes API client that transforms the API into commands you can run from your command line. And the three I strictly want to have on my machine anytime are Q. Q is a plugin manager that can go and install plugins for me into kubectl. Namespace and the context plugins also make your life easier, and you will see how. If you have had some Kubernetes experience so far, you know that changing the namespace you're working on or changing the context, which is the configuration of the cluster you're working on, takes a lot of typing. CTX and NS allows you to switch to context and namespace in a second in an easy way and saves your finger. Another tool that we will use today is Stern. Stern is a way to quickly look into logs of containers without going one by one into those. And I will show you that when we get to deploy DX. Git, of course, is because if you need or want or are looking to achieve infrastructure as code, you will need to master Git as the way to store away and version your changes and be able to go back in time to see what you used in the past. Okay, so the environment we are going to use today is made of 5 machines that I built as virtual machines. Probably we won't cover the DB2 part. It was just an experiment. We will see where we get. Operator DX is my client. It's a machine where I installed all the tools, all the client tools, where I downloaded the images and so on. And here I will be running Visual Studio Code, kubectl, and the Docker stuff for loading images and so on. Then I built 3 machines. This first one is my cluster master, and I have 2 workers. This one is, I will show you how the sizing is for this one and the sizing for the other 2. But by the way, this cluster master is 4 GB, 2 cores, no, 4 cores, and those 2 are 32 GB each and 8 or 12 cores. I'm running on a bare metal environment with Grafana. with Proxmox, and I also deployed in preparation. This is the only preparation I've done OpenEBS for my storage provider, and Prometheus and Grafana. We will install DX and see what happens. Okay. Questions so far? Are the, you can use the thumbs up or the feedback. I think you can have, no, I'm not sure you have the feedback buttons on the screen. Anyway, if you have any doubts or question or something is not clear, interrupt me or type in the chat. I have that on the other screen, so I can read through that in real time. So let's do it. First, we need to prepare and load our images. I did this already because the core image is quite large, but we can comment on that a bit. We will prepare the namespace where we will deploy the name. Oh, a namespace. I didn't cover that. A namespace is a resource. The session is recorded with, no, don't worry, and which will be shared on YouTube. We will talk about the namespace. The namespace is another kind of resource, is sort of partition of area inside your cluster that is parent to the resources you create into that. And we will create a namespace for the X, and to deploy, we need to create a secret, which is another abstraction. A secret is a resource where we can pull credentials or certificates or certificates key that can be used by the infrastructure. In this case, we will create a secret that will be used by the deployment system to know the password to our Docker registry. And we will also need to create a certificate for ambassador so that we give it a good name. I will use a self-signed one, and we will talk also about that when I get there. And you will need to check that you have storage classes that support RWO, read-write ones, and read-write many, and we will do that. Then we will deploy with HELM. We will go through the values of the HELM deployment of the HELM chart, and I will introduce HELM a bit when we get there, and we will extract from the chart all the values, and we will create a copy and edit it, and we will review how those variables impact the deployment. And then once we have deployed and the deployment is ongoing and we have to wait for some time, we will go looking behind the curtain, what gets deployed, what's the role of that, what happens, and how the things keep themselves together. Okay. And now we get rid of PowerPoint, and let me take a few windows away. Okay, we get rid of PowerPoint and we get into Visual Studio Code. I'm pausing a bit, a second, the screen, and I'm ensuring I have everything ready for the demo. Or it's not a demo, it's a deployment. So okay, okay.
Daniele, I have a question about the DB2 being in a VM, and why is it in a VM and not in Kubernetes?
Yeah, good point. I wanted to put DB2 in Kubernetes. I didn't have the time to fix it. And as I said, DB2 is a storage system, so you need to ensure that the backing storage of your cluster can support that. I'm running a large number of databases in Kubernetes, but for today, I didn't want to go that deep. But for me, it would make absolute sense to have everything in Kubernetes. In that case, my preference would be to have specialized kind of workers that have specialized storage that makes sense for that. So that it was a shortcut to have DB2 in a container quickly. Okay. No reason to not, no reason to. It depends environment by environment, because in the end, you pay if you are on OpenShift or on other non-vanilla Kubernetes, you are spending your money by capacity. And it's up to you to decide if it's worth having also the database in Kubernetes or not. So I think that it depends on you. That's my point of view. What do you think, Bill?
Yeah, I see a lot of times where we're doing this, where the database, not only DB2 but in other places, we just do the database outside of Kubernetes, and I think it's just for convenience sake, because we don't have as much experience with the database running it in Kubernetes versus running it in a VM, and it doesn't seem important. But I worry that it's making it seem like that's a recommended path, and so I just wanted to see if that was something that you recommended, and your answer is great. Anyway, it's not recommended to do it that way. If you want to have a pure cloud native environment, you would definitely run the database in Kubernetes as well. But if you want to, quickly, get things up and going and not deal with the database and learning it in Kubernetes, then you might do it the way you're doing in this lab.
It's all about experience. It's absolutely all about experience. So we will get there probably. We are investigating that.
Yeah, just a little bit of input for, you might find this interesting. I did some rounds of analyst discussions when we did the big launch of HCL Now and Sophie, and when I was briefing them on what we were doing with HCL Now and running everything in Kubernetes, they were like, "Really? Do you have some examples of customers running databases in Kubernetes?" No, I have, and this was from Gartner. Gartner said, "I don't have any of my clients," whatever this analyst was. I don't have any of my clients running their database in Kubernetes in production. Well, and I said, well, that's strange, because we do.
I'm running another kind of database in Kubernetes in production, which is Domino servers. And I have 100 terabytes of Domino databases running in Kubernetes. But we spent more than 1 year designing our workers to be extremely optimized for the task. So the point is, if you want to run a database, you need to absolutely master your storage management for that. So it depends on the value it brings to you, having everything in Kubernetes. As the work I'm showing today is the work we are doing to prepare our DX farm in Kubernetes. And we want to have everything in Kubernetes. But we have to be sure it just works, and that's the point.
Well, actually, what I've seen also from another project where we have also this discussion is, number one is, first of all, that the database teams actually prefer VMs over Kubernetes. Might be a skill knowledge issue or out of habit. The other thing is, databases provide a high degree of high availability, load balancing capabilities, etc. Yeah, like just think about Oracle RAC, etc. And running this in Kubernetes is actually mostly counterproductive. Yeah, as it's complicating things. And another thing is, if running databases in Kubernetes, database admins tend to complain about tools they don't have, root permissions they don't have, etc., etc.
Exactly. And my point of view, it's again about experience, because when people say DB runs in a VM, even workers are VMs. So in the end, it's all about abstraction and having things the place you want them to have. But we could go on for hours with this, because it's an odd topic. And when I told people I'm running databases in Kubernetes, people tell me I'm crazy. No, it makes sense for me from a cost point of view to have less management around. So there is no right answer. It depends. If you do that, eventually, maybe it doesn't make sense to spend the time to learn that. If you do that at scale, that it makes sense. So it's a matter of optimization. Okay. So now I already downloaded and prepared the images. So I will not load all the images, but the first step is going to, and let me get my infrastructure, is going to my machine and get into FlexNet and download the images. So you get a zip file from, and this is easier to do looking at the documentation because it would take a lot of time. You go and get the package of libraries, and then you need to load the images. For this, I want to point you to a video that's hidden in the documentation, not hidden, but referenced, and it's this video. And the suggestion is that you download the package, you Docker load the images to your local machine, but you then also retag the machines with a suffix that makes sense for you, like I've done here.
We can't see your screen, or you're doing this on a different screen, Daniele.
Oh, wait. Oh no, it's okay. You got okay. So
no,
you're right.
Now we see it.
Yeah. I rebooted my machine. Sudo systemctl start docker. I was showing this page from documentation. In the Docker image list, there is this video, and it shows exactly how to unpack and prepare and retag the images for upload to your registry. And you that have tried to deploy and learn that the images you get are tagged in different ways. So for your convenience, it makes sense to retag those the way that represents what you're doing. And I kept on my machine just one that I renamed to the other one and deleted. So I will show you on, let's see, I cannot reach that network. I renamed those machines, those images, in a way where I keep the names. I keep the names exactly as those provided by HCL, but I changed all the tags to represent the CF that I'm going to deploy. So I don't need to care about the naming. They come with. Okay. So I download the zip, unpack the zip, Docker load as in the video, and rename so that I can reference those. I upload it to my own registry, which is password protected, because you cannot put DX images in the wild. And I got that preparation done. Then let me get my slides, so I will try to follow the order I designed. Okay. Then when you have your images in place, you need to prepare your namespace. And here is what I've done to prepare for this demonstration. I created a folder on my client, and I created a set of folders where I put all my notes about things to do. Another tool that I use in the lazy way is Make. Make files exists for building applications, but you can also use those as a notebook, an executable notebook. So I created many folders in the sequence of things I've done to prepare. This was for preparing the underlying machines for the Kubernetes. And this is another thing, because the cluster I set up is running K3s. K3s is an easy to use and very lightweight Kubernetes distribution from Rancher. And I use this script that's called K3s where I can pass in a target machine and the credentials to get there. And with the free commands you see here, I created a Kubernetes cluster with a master and 2 workers in 5 minutes once I had the machines running. So if I go and see now my cluster, let me see in which folder I am. Okay. and I have this folder. And oh, one thing you can see, this is my shell. I'm using this shell, and with the extensions, with the extensions I have, my prompt has changed to show me the name of the cluster of the context I am and the namespace I'm in. So I always know what I'm looking at. And the other thing is that if I am in a Git repository, this prompt also shows me where I am and what I'm doing, in which branch I'm working, and so on. So this is a very simple improvement when I use that I have when I use Kubernetes. The second thing that is really important for me with Z shell is that I get a number of aliases, because if I want the list of nodes, I will need to type kubectl get nodes. Kubectl get nodes. And if you think that every command is kubectl, one thing that comes handy from Unix shells is aliases. So Z shell provides me with a very simple alias, which is K, and K is the shortened for kubectl. So you will see me using K get nodes and K get nodes or K whatever every time. The second thing that modern shells provide you is auto-completion. So if I run K get and I tab, it provides me with all the possible values. If I type node and type tab and tab over it, it completes the command for me. So it's helping me running the right commands, and we will see that also helps me with all the objects, because the auto-completion is aware of how to get the list of things around. Okay, and now we are with this 3 nodes cluster, and I can get the namespaces, and kget is the way to get objects from the Kubernetes environment, to list objects. So I say kget ns, and this is the set of namespaces, those logical partitions I have in my cluster. And you see that I have one for the storage system and one for the monitoring, where I deployed the monitoring. And then there is the system and the default namespace. I deployed the Prometheus and Grafana stack. So whatever we do will be, oh, here we go. We will have dashboards telling us what's going on in terms of the size of the cluster, the CPU load, the aggregated thing, and this was just another command that I ran to deploy the thing. So this is also what you get in a different way when you deploy a SOAFEE solution. So visibility into what's going on is something that's today considered a must, and that is relatively easy to achieve in a Kubernetes environment. So I deployed this because we will then be able to see what's going on in terms of capacity. Now, the next step for us is to create our registry secret. And create your registry secret is fundamental. I'm jumping over the preparation and getting to the X. And here I have all the commands I'm going to use to deploy. So I will create my namespace, kubectl create namespace, and I'm using make, as I said. So make, and the label here is the name of the target. And once again, auto-completion help me. 01, no, not oh, I have to enter the folder. I need to be into the 30 DX folder. The numbers are just a way to get an order list. And now I can make, if I tab, you see that my shell has detected all the values that I have in the make file. So now I want to create a namespace. And this way, I'm also documenting what I'm doing. So now I'm creating my namespace for the xdeploy 01, which will be the container of the stuff I deploy. Okay. Okay, now if I go and get the namespaces, you see I have this new namespace. And I want to switch to it because I will work in that context. And here I'm using the Kubernetes kubectl namespace plugin that allows me to just get a list of environments and to type ahead to select the one. When you have many, the alternate way is a very long command. KNS gives you the convenience to jump around and get in the place. And my command line changed, and it's telling me that I'm working in this namespace. Okay, Herman, I don't get your question. Doesn't the DX deployment require the user ID 1000? In which context?
Well, actually, at least on OpenShift, you need to create a namespace with specific UID from the image where the WP admin user running inside the pod is actually, I think the UID is strictly set to 1000 and the group ID is 1001.
It is okay. I don't need that.
UIDs in OpenShift, at least it gives you headaches later on, and you need to grant special permissions to the user.
Okay. I don't need that because actually the UID is a number, and if I have the file system created with that owner, even if the actual user doesn't exist, just works in Kubernetes. So I'm not doing that. Okay. The point is that when we will create the storage, we need the storage to have the rights to have the rights to allow the user to write there, and that's the first source of headaches when you try to deploy. And I have a suggestion for the DX team, but we will get there later. And then the second thing is we need to create a secret, so a user and password alias that we will use for getting our images from. And I will run this in my screen so you don't see my password and it doesn't gets recorded. And this secret will be needed by me to access our registry. I'm doing that. And then we show you the results. Am I in the right way? Okay. I'm getting there. Now. Okay. And here you go. Where is my screen sharing control? Okay, so I created a secret, and this secret contains the information, the user ID and password to reach out to my registry. If you don't do this, your deployment will fail. I could be deleting that when we do the actual deployment to see it fail, but I want to save time. The other thing that is mandatory is you create a certificate to be used by the ambassador environment to access your system. And here we use OpenSSL to create, and I copied the commands here exactly from the Help Center. So I'm going to run this. This will create another secret containing a key pair that's that will be used by the certificate. So it's generated the key and deployed that. So we now get the new. Okay. Oh, I have to install it. I just created that, and now I have another command, which is create secret of type TLS with this name, which is the default one, and I'm importing the two files, the certificate and the key. And you need to get also expert in handling certificates with Kubernetes around now. And now, I should use auto-completion more. And now you see we have this new one. So now it's time to deploy, but how do we deploy? We are going to use HELM. HELM is a tool which uses this specially crafted targz file that contains instructions on how to deploy an environment. And HELM, we are actually using HELM 3. HELM 2 is now legacy, and I hope you never have to do with it because it was much more complex. And HELM has various capabilities, and one is to show values, passing a chart, is able to print out, and we are storing those, redirecting to a values file, the value that you can fill. So this is the list of parameters that you can tune to deploy DX. And the default one need you to fill the pool secret, need you to define the tags for your images, and needs you to fill also the name of all the images for the components, okay? And then you can define the resources that you want to assign to each pod, to each container, no, to each pod in the deployment. So this means the CPU unit is intended into milli-cores, 1,000 of a core. So the default deployment is going to use 2 cores per DX portal environment, and this is it. And all the things can be tuned. Also, you define the requests in Kubernetes terms. A request is something that needs to be provided or fail. So if we don't have 6 gig of memory available when the pod is starting, it will just fail. But we are also putting a hard limit into how much memory the pod is going to consume. So we can fine tune everything here for each of the components. And then after that, there is the scaling side. We will not cover this today. It's for the automated scaling of DX. When more load comes in, this would need another full day presentation to discuss auto-scaling in Kubernetes. Also, node selectors are rules that allows us to put specific spots into specific workers, and this is for very large environments. And volumes, and this is where we go defining the rules for the storage. The default suggests we use storage class name manual, which probably doesn't exist on your environment, and just means that you are going to create the volumes before the deployment and giving name here manually. I'm not going that. I want to go full automation, and I think that it's important to show, because time is running over. In my machine, in my cluster, actually, I have a number of storage classes. You remember SC storage class. And I have created 2 that I'm going to use: OpenEBS read write once and OpenEBS read write many. And you will see in my configuration that I use that. And I will now start the deployment command, and then while it works, we get back to completely check out the values. So it takes time, so it's good to do that. I'm using a slightly different command from the one in the info center, because M3 allowed introduced an idempotent command, so you can run an upgrade even if nothing is installed, saying that if it's not installed, do like it wasn't installed. You give the name of what's called a release. A release is a label, is a title you give to this installation. you pass the chart name, which in our case is that chart description file that we have seen before. We pass a file where we store all our customization parameters. We pass the name of the namespace, which is the one we created above. And we also pass that link that says, if it doesn't exist, create, but we should have created that beforehand. So I have to run this. I created my alias, but I could even run this on the command line, and this will do the actual deployment. And let's look at this. Release doesn't exist, so I'm installing it now. And the first thing that you see, it is deploying some custom resource definition. And the message we get here is because the format of CRDs that are deployed is deprecated, and the HCL team needs to update those before 1.2.2 is out, because in 1.2.2 those will be gone, and we could not use this M chart in Kubernetes 1.2.2 plus. And now it's done. Well, the M chart has created all the logical resources declaring what we need to achieve. So I can go and get the pods. And you see that all the pods are in container creating status. In a normal environment, at this point, Kubernetes would go out to the registry and get the images and download the images to the node, and then start the container. In order to save time, I already pulled the images to my node, so now it's a bit faster. And you can see a few things now. Let me get the wide view for the pods. We have one ambassador, because I set it to be one, 3 Redis, 1 content composer, 1 core, which is WebSphere portal action, 1 design studio, 1 digital asset manager, 1 open LDAP, 1 image processor, and 1 of all. But you see that the node where they got deployed is different, because we have 2 workers. So the system automatically balanced the load out to the others. The last 3 that you see is my load balancer in my cluster that is taking care of exposing DX, and we get there in a second. So the very first slide that I showed discussed about deployment, stateful set. And let's start getting those. And what we learned is that that DX is deploying Ambassador, Content Composer, Design Studio, Image Processor, Ring API, and so on as deployment. So an ordered environment that can have multiple replicas to scale up. Those applications that are deployed as deployment are in general stateless, depend on other services, and that's it. Stateful sets are much more, as the name implies, stateful. So we have the core and the digital asset management and the open LDAP and so on deployed as stateful set. So it means that the day we scale those up, those will be managed in order. It depends on how you reboot things. When you reboot a deployment, it can just start a new pod, delete the old one in parallel at times with no disruption. In a stateful set, things are managed in an ordered way. So you first stop node 3, node 2, node 1, and then you restart in the process. So it's about the orchestration side of things. And what else we got with the deployment from the M child? We got services. Services is another resource from Kubernetes. You don't need to learn all of these, of course, but it's rules, logical networking rules that tells you the ports and the IP address internal to the cluster where you can reach for the services. I want to bring your attention to this one because this is a special one, the load balancer. And the load balancer means that we expect Kubernetes to provision an IP that's load balanced in the environment and exposed to the outside of the cluster for consumption. Okay, so in my environment, it got connected to all the nodes and it's exposing port 80, port 443, port 94.3, and port 1636. And Ambassador is taking advantage of that to expose the things. In a normal on-prem cluster, you might not have a load balancer solution in cloud environment that's in general given to you by the cloud provider. Now, let's see how the deployment is going. Over time, you see that more and more environments get ready, and you are seeing that my core and digital asset management is taking more time because the provisioning mechanism for my storage takes more time to serve those. So now we look at what kind of storage DX requires. And now we go and look for persistent volume claims. And you see now what we required. We required a bunch of, let me grab. This is write once storage. So each of those doesn't need to share anything. So this is read write once. And what's using read write many storage? The DX profile and the digital asset management system. So those are being provisioned. And when we are here and we look at this, how do we know what's going on? And this is a part of the troubleshooting skills that you need to learn. So whenever you need to figure out what's going on, the first thing is to get the resource in a list, to check the status. And if you want details, the right command is kubectl or k describe pod name of the resource. This gives you a human readable description of how that resource is configured. So I'm looking exactly at how this container is configured and running. But the most important thing is at the end, in the events output, that's telling me what's going on. And it's failing to mount the share volume, the RWX volume, because my provisioner is working and it's taking a bit of time to provision that. This will go away in a second, in a few minutes, when everything is ready. So it's really dependent on how your storage is provisioned. And this is the reason why you might want to pre-create the volumes and to pass in the volume name. So once again, it depends. If you want everything to be automated, this is the way to go. If you are doing a single deployment, the easiest way is to pre-provision resources. Okay, I see question I get there. No, now we talk about Ambassador and we talk about the questions coming up. So everything is clear so far. Okay. Ambassador and ingress. Ingress is something you bring with your cluster. And Ambassador is something that HCL decided to use. Ambassador is not Nginx. Ambassador is a product, is an open source product that inside it has another technology that's called Envoy. Envoy is a high performance HTTP and TCP server that does a bunch of things. And I think, this is my guess, my understanding, and I think that the right people to comment is the HCL team. Ambassador is used and brought in by DX so that they can design and control the flow of information inside the DX deployment, regardless of what you are running as your ingress. Because I'm going to show you one thing, that when the deployment runs, they are creating some custom resources that are ambassador resources called mappings, saying how to route the traffic. So they are exposing IBM console, HCL wizard, the site manager, the image processor, and so on. And they are explaining to ambassador how to connect the dots. So HCL has designed the solution so that they get the URLs exposed all through a single component, which is ambassador, and that ambassador is exposed outside of the cluster using that load balancer service. As soon as the portal gets started, I will get you in and we will see how it's working. One thing I will ask for a change is that in a non-OpenShift deployment in Kubernetes like here, you can only get a load balancer, okay? But what if I want to have DX behind my internal ingress? In that case, I would have loved to have the possibility to select the type of service being created so that I can have my real ingress respond and route the traffic to the DX environment. But I think they are working to extend the possibilities. So I was just referencing this. And let's see how much time. I will switch to my OpenEBS environment. You see, I changed my namespace and I'm checking. So, okay, the first NFS serving system has started. So I think it's just getting ready. And let me get to the deployment. I'm switching between the rooms where I keep my racks. So my environment is allowing me to switch between one and the other. And I give it some more minutes and I go back to the deployment values and to your questions. So Andres, Ambassador is not Nginx. Ambassador is something that exposes the DX environment to the outside. Beware that given the way it's deployed and the mappings we have, if you deploy DX on the public internet with, let's say, Google or Amazon, you could be having the console and the wizard public if you use the standard load balancer. So keep this in mind, okay? And I don't know if there are switches to not publish those, but it's a thing I want to check, to look into. Now, how I deployed, I created my custom file. And I set my pool secrets so that when Kubernetes goes out to my registry, it knows how to authenticate itself. I got all my tags where I retagged the images and all the container images names that are the standard ones. Okay. I set my resources. I went with the default. So nothing special here. I didn't enable scaling and auto scaling, so I used the standard numbers. And no node selector. And the volumes I set the storage class name I want to use. In this case, I'm not setting the name, and the PVCs, the persistent volume claim, are created with the storage class. When a persistent volume claim is created with the storage class provisioner has the task to check for it and to create the storage accordingly. So I just set those by the need I had. And I defined which applications to deploy. I also enabled the beta of Design Studio that by default is disabled, and also the OpenLDAP. And we get to the networking, and this is very important. This is the default host name that the deployment will use. This means that by default, all the sub-services have CORS enabled to respond to these hosts. And you should have these as the default portal for you. But in general, the deployment is set so that you can use any host name to reach that. What I did here is I made the host name exactly the same of the certificate I created at deployment time. So I have the name matching, even if it's self-signed. I set SSL to be enabled and mandatory. I'm not changed the context root and the URLs for portal, so I'm deploying the classic way. And you can also, for all the add-ons, define the list of CORS origin that you want to allow. If you are going to use host name based virtual hosts, or if you are going to use multiple host names for your brands, you will need to list all those in here if you want the additional components to work, because CORS is mandatory. So in this case, we don't need it. If we do that, we need that. Here you have the reference to the certificate, and then I've not changed that. And as I'm not on OpenShift, I'm not using this. Security is where you can go and customize a bit of your credentials. And also here you can customize the user and the password for the PostgreSQL that's serving the digital asset management component. And so here is everything, and you can also change the probes. Probes are the mechanism that Kubernetes uses to check the health of your application. So each component has its own set of probes. And that's it. What else is relevant in here? Oh, about logging, I think that's new in CF 199 is that for the core, the portal side, two sidecars, two additional containers are run that are reading out the files for you so that your logging solution can capture those in an easy way. And we get to see what that means now. And the metrics, I also enabled metrics to be generated so that my Prometheus mechanism is able to get those information out and to see the data. Okay, and everything else is about, oh yeah, you can enable LTPA token and pass the information to be imported and injected to participate in a single sign-on scenario, and so on. Okay. So let's see how it's going. It's still not ready. Okay. And this, the troubleshooting session begins. Let's see what's happening. Because this storage provider proved to be somehow challenging. Okay, for volume, you see I'm describing to see what's doing. Object is being deleted, okay, successfully assigned. Fails. And I should have used the easy way with an NFS volume, but And one thing you will learn is that at times you just delete pod and it gets recreated because some condition failed and so on. Well, you shouldn't delete the pod where you're running your application. And it gets. Bye, Robin. And let's see, I deleted those. One already recreated in 11 seconds, and the second one you describe and you try to figure out. Okay. Now we look at the volumes that have been created and all are bound, so almost ready. And we need to see what's happening with this. But it's waiting to be started. It has been assigned, but it's waiting to be started. Now I go back to my deploy. Okay. I want to also accelerate the restart. So, because when Kubernetes fails, instead of retrying forever as a mechanism, which is the backup mechanism, where it tries, it fails, it doubles the time to the next retry and so on, till it gets to a status where it can recover. And from time to time, it tries to recover. Now, I want to see what's happening here. Okay, it is assigned. I would have expected it to be starting. Okay, unmount under progress. So I have to check one thing. Get the storage pool cluster, which is failing. No, it's healthy. So okay. Let's see. We do one thing now. I'm going to drain all the servers off. Opening, yes. Let's see what's problematic here. The problematic pod is running on the node 2. And now I'm going to do a very drastic thing. I'm draining that worker. I'm telling, oh, I want to put out of service that server. And well, it complains because some system is running there. So I'm going to say, okay, let's force this because I know what I'm doing. And then it will tell me once again for another kind of thing I want to force. That's not the thing you should do in production right now, because this is evicting the pods. It's telling processes running on this worker need to migrate and be restarted elsewhere. So I'm going to, I'm draining that node. I'm having all the processes restart on the other one. And it's telling me what's going on, because probably on my node 2, I had some issues. And now I'm forcing everything to run over the other. And you see the number of objects that are moving away right now. Okay. Evicted, okay. Evicted. Because everything was running on node 2 and no, but I had, okay, let's get this completed. Okay. And now you see that stuff is restarting on the other side. And you see now that my node 2 has scheduling disabled. So now I can log in there. And reboot. And it will be back in a second. You will see that. Oh, I don't know if you know another handy tool, which is watch. Watch keeps running the same command every few seconds and giving you the behavior. So our node 2 is going down and will be rebooting in a second. Okay, and it changed to not ready. I want that when it gets back, it can still get work. So I'm going to kubectl uncordon the node. A cordon around the node means don't bring workloads here, or uncordoning means it can get workloads. So I'm cordoning it, so not nodes, but nodes. So we are running everything in node 3. Get GP is kubectl get pods. Okay. It's container creating a node 3. Okay. And DX deploy. In fact, digital asset management is now running for the DX core. We are still waiting for the storage. I picked the wrong engine, I would say. Describe. Oh, no, sorry. This is not that. This is because I never ran the portal on this node. Now it's pulling the image from the registry, because you need to have the image pulled to the registry to be able to start. So that makes just sense. So while we wait for things to clean up and get to run, any questions that comes to your mind, guys?
Why aren't you done yet?
Because I'm not as good as Sophie. No, because actually
You ask any question, right? It's Friday afternoon. It's 5 o'clock. Why is it not running yet?
Oh yeah, because there is suspense around.
Fine.
No, I did an experiment with this storage provider. I wanted to see how it was working, and I deleted these right before the demonstration. So I wanted to have the demo effect side of things.
So do you remember Murphy's Law?
Of course.
Yeah. Okay.
No. But actually, beginning of this week, there was not even the bare metal server I'm running this over. So,
Wow. So
so
taking
I
big steps
spent
here.
some days. But now I know for sure that this OpenEBS tool is not in my future, but it got provisioned. It got provisioned, the file system. So we will see it start in a long second, as soon as it it's creating right now, which is good because it got everything. And
if I may say, if you are in the future, if you are able to use Sophie, you can easily access to the logs files as well to see what's going on and things like that. It's
good
so
point.
a lot of things very easy.
But I have my own version. I want to introduce Stern. Stern is a very handy tool which allows you to query for the logs of multiple pods without getting too crazy. Because normally what you do is kubectl logs name of the pod. And that's annoying because you can do that one by one, okay? Stern is a tool which allows you to use a regular expression on pod names to get all the logs together, color-coded, and to see what's going on. I think that it's finishing the pool of the core image. Let me see exactly. Probably it is expanding the. Let's see exactly. It's starting up. Startup probe failed, but it's starting exactly. Now it's running, and now we want to follow all the logs from this container. As I said before, the portal is made of 3 containers: the core, the system out log, and the system error log. So this tool is going to show us all the logs from all the files together, and you see that it has expanded the file system to the external volume. The system out and the system error are saying, oh, I cannot find those files there. So we will need the portal to start and to be processed. So this is the first start of the portal, and it's initializing itself. So it's doing the initial expansion of the profile. It will run all the tasks to deploy the additional components and to configure the resource environment providers things. And I'm not sure right now, because I don't know what the runtime controller component is doing at this time. If it's actively participating in the deployment, or it's just scripts in the core that controls what gets deployed. So this is doing the initial tuning, and we are not seeing anything right now. But if we get the pods again, you see that there is this interesting runtime controller thing that is processing things and ensuring that everything gets deployed. So I don't know exactly there is no documentation on this component because I think it's still early, but deployment is proceeding. And now it is running the initial tuning. And one thing we can do, because we are curious, is we can also enter the pod and see what's happening from the inside. And kubectl exec allows us to be inside the container and see what's going on. So now, right now, I see that it's enabling all the add-ons. So we will need to wait for that to happen. And let's see. Okay, something else. Exactly. Initial tuning has completed. LTPK import was not requested. And now you are finally seeing something that you know. This is the logs from the web surfing, and those are getting out to the system out log emitter or container that allows our log capture to happen in an easy way. So this, I think, was introduced in 199 and is going to help a lot with troubleshooting. And now, from now on, it's all a matter of waiting for it to complete and to do the process. So I would say it's a good time to have questions, and then we see the final thing deployed in the end. Because I talked a lot, we are somehow getting there, and I want discussion. And not just Robert.
I'm not asking anything right now. I want others to do that.
Everybody seems to be deploying at their place because it was so clear and understandable that they are doing them themselves. No, I'm joking, but
Do you remember your first slide?
let me get that. Was this one or this one?
This one.
Okay. Possibly. Okay. The good thing is that once you get your, well, regardless of the storage thing, when you get the storage that's more reactive than the one I'm using, and when you get in a sequence all the steps that I've done here, deploying more becomes an easy thing. Not easy is a wrong word. A very productive thing. You can deploy, you can have, I could deploy another one just by creating another Helm chart values thing and deploying that. And so it's good for environments where you have multiple environments and you want to keep those controlled by configuration resources. So,
Daniele?
yeah.
Have you tested the scraping of BMI values, etc., for using Prometheus?
I deployed that, but not tested yet. So I'm waiting for the deployment to complete, and then we can go looking into that, because the next point will be building some, let's say, dashboards for those. Actually, I have not even checked the statistics that those are exporting right now. It's a thing to do, actually. And I can tell you one thing on how they have implemented that. It's an ER file that's deployed in WebSphere.
For VAS, I guess they're using the standard VAS provider, right? Because VAS, since I think 9057 provides a Prometheus exporter.
Okay, I wasn't aware of that.
VAS.
and they are running that on a specific port using a separate thread pool. So you should be able to get the statistics even if your web container thread pool is overloaded and so on, and that's a good thing. But I have to investigate more because it's quite new and I've not yet tested it out. The other thing that when I tried to do the database transfer, and I learned that the config wizard is exposed to Ambassador, is that the container does not contain the DB2 driver. So when you want to do a database move, you have to copy into the profile your driver yourself, which at least for DB2, I think if possible, that would be a very good thing to have that in the standard image. I know that customers are also running on Oracle and so on, and there could be some distribution limits, but for DB2, it would make sense to have that in the core image. So one less step to do.
Well, probably that's a licensing issue.
Sorry?
Probably that's a licensing issue as well. You know, I know DB2 is licensed, but still not sure if they're allowed to deliver it in their image. You know,
yeah, and
comes to legally, whenever it comes to legal, it's not necessarily not logical.
exactly. And possibly one solution is to create a script that just injects because I know that the DB2 drivers are somehow available on public repositories. So I want to check that out, actually. So for the moment, DX is using only Docker images. Romain, I don't know what you exactly mean.
Yeah, hello. In fact, I heard that Kubernetes is now more supporting Docker as container runtime. So I was wondering if
okay, we need to clarify what it means. The images, the container images that we call Docker images are actually already independent of the runtime.
Okay.
So the images are not going to change. The DX images are built on the Red Hat UBI 8 base image, which is a stripped down version of Red Hat Enterprise Linux image. And the format of images is not changing. What's happening with Docker in Kubernetes is that with the evolution of container technologies, the architecture that made Kubernetes depend on Docker is not needed anymore. So it's easier to, what they announced is that Kubernetes will not ship Docker integration in the binaries directly. But Docker has announced that they will anyway provide a package to continue to have Docker as the runtime engine for Kubernetes. So from a user point of view, from a developer point of view, it's not going to have any impact on you. The stuff I'm running right now, the worker nodes have no Docker installed at all because I'm running with containerd.
Okay.
So you should not be worried too much about that. Okay.
Okay, thank you.
You just have to distinguish between Docker as a client command and Docker as the runtime, the container runtime. And actually, there are different container runtimes, like Docker, Podman, OpenShift, for example, uses Cree.io, they are all Docker-D runtimes, different implementations.
Exactly. So I'm waiting for the deployment to complete. It got stopped and it will now restart. I don't know which step of the deployment we are in, but it takes a few rounds to run. And there was another question from Andres. No, as far as I know, well, you can import the images in containerd without using the external repository. And you can do that, but you need to do that for each node, which is, let me get into my node, HCL DX 02. If I do this, okay.
Actually,
No.
Daniele, one question. Do you know K9S?
Oh, yes. I'm not used that too
quite
much.
handy for working in this environment.
Yeah, I know that. K9S is, let me show, so we share with everybody. K9S is a command line tool that's extremely useful to look into stuff, and let's install it. Let me do the easy way. Release. Here we go. Copy link. We go back here. No, not this one. And this is what we are looking at. Yes, very useful tool, almost visual for the command line to get into containers and to see what's going on. You can see it gives you which container is running at X maximum, and you can also enter into the pod and see stuff. Oh yeah, this is not logging because right now the action is happening here. So this is a very useful tool. I didn't mention, I am not using it, Herman, but I should. I really should.
Well, actually, it's just another tool, but I think worth looking at it. At least I think, because it makes it just easy to access the bots, etc., access the logs.
Exactly. So yeah, it's a very useful way to go and check what's running in your environment. And you also have shortcuts to jump over the multiple namespaces. So yeah, this makes a lot of sense.
I always say it's like VI for Kubernetes. Because you can search with slash, you can search for bots, etc. We have a long list, so it's quite helpful.
Yeah. I wanted to at least get to the point when it's running, so to show in the end it works. Because I have everything running but portal, and it's saying it's open for business, but I'm not sure because I'm deploying everything. So now it's importing even more stuff that probably would be needed. And they can try and attempt the XO1 and see if it's ready or not. You see the self-signed certificate. No, it's not yet ready for me. because it's deploying. Which, well, it takes a bit of time because in the end I spent time with explanation before starting and also with the troubleshooting, but it is working anyway. Other question or suggestions on idea? Oh, conclusion about setting up the storage. Test it out before you get to deploy, which means if you have an enterprise NFS service or an enterprise solution, use that. Even with volumes you pre-create, if you want the full automation with full provisioning, as I showed here, you either get into a cloud environment where is the cloud provider business to provide you with a solution to automate that. So that's the approach of HCL now and Sophie running on Google Kubernetes engine, or spend the time to achieve this kind of automation if you are going to run it at scale. So storage is the hard part of everything, even without Kubernetes. In VMs, we are used to have no issues because mostly it's VMware solving the problem for us. But in a dynamic environment like Kubernetes, it can be complex. So if you are in the I'm learning side of the story, take the easy way. So the easiest way, I wanted to experiment OpenEBS because it was on my R&D list. We are also running stuff on ZFS, but that's something we do for other scenarios. So the summary, Alexa, stop. The summary here would be, don't complicate your life, especially when you want to avoid frustration in learning. So go that way. And the easiest way for read write many environment is to use an NFS storage. And that's it. To me, running the database also in Kubernetes can make sense because I don't want to patch multiple systems, but it takes a lot of tuning and experience. So we are on day one right now, from my point of view. But as I said at the beginning, this is my experience so far. I'm really looking forward to learn what others see and what happens for others. So any feedback is welcome. Okay, I use traffic by default on K3S. Yes, but I'm using K3IS only as a shortcut. For my production environment, I want to use RKE with Nginx or HA proxy ingress controller, which is also a very good option. And once again, the point is, if you're doing DX deployment in Kubernetes every day, you will learn one way or the other. If you do that from time to time, or you are starting with a first project of its kind, take the easy way. You always have time to improve. Oh, running locally. I'm getting back to Antonio. Running locally the hard way. I would use an NFS provisioner that just carves out volumes from an existing NFS storage, and I'm going to throw away what I've got today and rebuild that way to validate that that's a good way to get there. When will DAM support a database that's not in containers? That's a question for HCL, and probably we spill that over to the Discord channel. So I'm going to not stop here. So if you need to go, but I want to get to the end and record and access the portal at least once. So if you have more questions, I can extend the session, no problem at all.
Daniel, thank you so far. And I need to drop off, but wonderful to see how far you got in 2 hours.
Okay, explaining with explanation.
Yeah, including explanation. I mean, 2 hours is not a lot of time to run, get this up and running. So thank you so far and keep it recording.
Okay, thank you. And let's get
A lot, Daniele.
A great job, Daniela. Thanks for building the structure and being so complete on this.
I think thank you everybody for participating. And again, if you have more questions, okay, let's see, this could be it. Not yet, because one of the things that that Ambassador is doing for you is to ensure that the traffic gets to the environment only when readiness is okay. And as you see here, the ready column is telling you about how many containers should be running and how many are ready. So this means that we are not yet ready to serve the outside traffic. We see now how long it will take. Okay. Oh, next pod start complete. Could be. We are getting there. I'm not seeing.
Are you running
anymore.
Kubernetes on Minikube?
Sorry?
Are you running Kubernetes on Minikube in the server?
No. This is K3S, and I have the underlying infrastructure is the machines here. It's free OpenSUSE servers on kernel 5.3 with K3S, because I'm also doing software selection about the various options out there. So this is the most unsupported environment that you can possibly imagine from an HCL point of view. This is vanilla Kubernetes 1.20 on K3S with containerd and a pretty weird. Okay, we are getting in, and here you go. This is HCL DX for you.
Great.
And we are here, and let's get. And I noticed that it's pretty fast once it gets. Well, this is the warm up and the initial startup, but it works in the end. And I'd like, now that you know that it works, I'd like to bring the discussion over to Discord. So any question, sharing your experiences, your successes is what we need, because we are all in the learning phase right now. Yeah, PMI on Grafana. And yes, let's see, I got this. Thank you, Antonio, for assisting. Okay, I'm in the portal and it just works, which is something I wanted to have. And yes, this is the new collector. I set all of these. I'm not yet sure that my Grafana is collecting those. And it would take too much time to go out and figure, because I don't know which metrics to look for, because I'm not sure when I'm not sure. No, I don't know exactly how.
The CPU is a good one always.
Sorry?
The CPU one. Search for CPU.
But CPU isn't one of the PMI metrics.
PMI. No, it has not yet picked up the PMI scrapes. And that's, I mean, I will keep this infrastructure alive, and because it's my lab, and I will get everything. And probably I can post some short videos to the Discord channel as soon as I get it working. Okay.
So I'm not sure if that helps, but in that page there was some information about some dashboards that I guess you could import or something. I'm not sure. I've never used Grafana myself, so.
Yeah, those dashboards, as far as I know, were for standard. Oh no, okay, those one. Oh, I can show you this. I didn't notice that. So when you import, you can just put in the ID, and it imports the entire dashboard for you. But as you see, I have no data because probably I'm missing some part of the configuration. So yeah, from importing those dashboards, oh, if I do this, I should be probably getting something good for the Node.js applications. Not yet. And Postgres. Oh, this was news because when I checked it, it was not yet in documentation. Okay. I will complete the setup and give feedback on this. Okay. So importing, in fact, the next thing is to build a dashboard which is relevant to DX data. So that's it. Okay, we got it working. I'm quite satisfied about that. It took more time than I expected, but we did it. And thank you for all the questions. Take a look at CubeView. Okay, I want to take a look at that. Thank you everybody for participating, and bring more questions to Discord so we can discuss there. Okay. Bye-bye, everybody.
Yeah, bye-bye, Daniel. Thank you.
Bye.
Bye-bye.
Thanks a lot, Daniel. Bye-bye.
Bye. Have a great week, everyone.
Zoom.